Hello everyone and welcome back to PostNetwork Academy. And in today's video, we will explore the relationship between covariance and standard deviation. And we will derive an upper bound using powerful Cauchy-Schwarz inequality. So here what you will learn: definitions of covariance and standard deviation, the Cauchy-Schwarz inequality, and step-by-step example to calculate covariance and verify its bound. So let us start it. So covariance, sample covariance. So that is 1 upon n minus 1. Basically there are two types of covariance, sample and population. So I am using the sample one. So sample one would be 1 upon n minus 1. Summation over I is equal to 1 to n, xi minus x bar and yi minus y bar. And sample standard deviation, so sigma x under root 1 upon n minus n, summation over I is equal to 1 to n, xi minus x bar square, and y under root 1 upon n minus 1, summation over I is equal to 1 to n, yi minus y bar square. And here the Cauchy-Schwarz lemma or inequality states that summation over I is equal to 1 to n a I bi square is less than or equal to separately summation over I is equal to 1 to 1 ai square into summation over I is equal to 1 to n bi square, where ai is, you can say that xi minus x bar and bi, that is yi minus y bar. And if you plug these values, so you will get covariance xy that is less than or equal to sigma square x sigma y square. That means covariance square is less than or equal to sigma x square y square. And finally what will you get? Covariance is less than or equal to multiplication of standard deviation. So we will verify through examples that if you multiply standard deviation, so you can get upper bound of covariance. And see that I am explaining these things because if you understand these things, so you will understand the covariance formula, a correlation formula given by Carl Pearson. So let us see that, and let us explore and verify. So see that if I take data 1, 2, 3, 4, 5, that is ux, and y, that is just opposite. So if you compute a standard deviation, so that would be, you can say that sigma x sigma y both would be equal 1.58, because see that order here doesn't matter. X variance, x standard deviation, y standard deviation, both would be same, and that would be 1.58. And if you multiply sigma x sigma y, that would be 2.50. And see that covariance can never exceed 2.50. You will see that I have taken three cases so that you can understand. Now I have taken 1, 2, 3, 4, 5 completely opposite direction, and 5, 4, 3, 2, 1. Here covariance mean would be 3, so you will subtract and you will add from 1 to 5 and you will divide it by 4, so that would be equal to minus 2.50. And if you take the mod, so that would 2.50, and already sigma x into sigma y, that is 2.50. So this inequality holds. So upper bound again here 2.50, even that is opposite direction, data were in opposite direction. Let us see another case. Here some data are you can say that matching, not all are opposite. So see that here x bar is 3, y bar is 3 always, and covariance you can see that we have calculated. So here covariance would be minus 1.50. Again in this case inequality holds, that means upper bound is sigma x sigma y. Third one, the same data for both I have taken. So in this case variance would be the highest. So here again sample size 5 and we are calculating. So if you calculate, so you will get 2.50 or 2.5, and again this inequality holds. Even x and y are same, so in this case the covariance would be the maximum, but it is not exceeding 2.50. So you can see that you can check another cases. Just I have taken 5 data points 1, 2, 3, 4, 5 in x and y both, and you can check for any combination, means x is some value and y is some value, that will come always less than 2.5, and multiplication of sigma x and sigma y is 2.50. So you can see that covariance xy mod is less than or equal to sigma x sigma y. That means sigma x and sigma y, if you multiply, so they are upper bound for covariance, and this will help you to understand correlation, Carl Pearson's correlations. You will understand it easily. So hope you have understood what is the how covariance is bounded. So you have got upper bound. Hope you understood this concept. See you in the next video. Thanks for watching.